Hello, everyone. Welcome to another edition of SpaceAg Conversations. Um, my name is David, and I'm one of your hosts for today. I'm based in California, and my normal co-host is going to be our special guest today, Davi. So
Hi
we're
everyone.
excited to have him as our featured guest today. Um, While we're waiting for folks to kind of trickle in over the next couple of minutes, everyone please introduce yourself on the chat and tell us where you're from.
Don't be shy. Feel free to put on the chat.
Okay, Richard from California, Nico from Greece, Kalimara,
Greeting, greetings
Kalimara,
from Turkey here.
or Kalispera, I guess. Someone from Illinois, someone from Indiana, great. Italy, Netherlands, Lithuania,
That's
amazing.
great.
Good evening, I guess, in Lithuania. Someone from Panama. Okay. Amazing. From Germany. Okay. Um, okay. India, Brazil. Well, it's wonderful to see that we have a very global audience. Japan, Bulgaria, Saudi Arabia. Amazing. Okay. It's wonderful to see that we have a global audience and that there's interest all around the world in space agriculture. So, um, before we get started today, just remind you if you have questions for our speaker, for Davi, as the webinar goes on, please add your questions into the Q&A, and then we will look at the questions at the end of the presentation when we have after he finishes his presentation, we'll have sort of a Q&A period. So let's see. So the agenda for today, we'll just talk a little bit about the SpaceAg series, and then we'll get into Davi's presentation. Then we'll have Q&A, as I mentioned before, and then just a few closing notes about the SpaceAg course that you can take and how to get a certificate of attendance from today's session. So just to remind you, if you're new to the SpaceAg series, Davi and I have been doing the SpaceAg series for a couple of years now. We have SpaceAg Conversations, and SpaceAg Conversations are with experts in the SpaceAg industry. So today is our sixth SpaceAg conversation. And so our 5 previous SpaceAg conversation episodes are available to watch on YouTube. They're all fascinating. So please feel free to check them out in your free time. And we're trying to schedule probably like 2 more SpaceAg conversations in 2026. If anyone has suggestions for guest speakers or suggestions for topics that you would like us to discuss on this webinar, please send us a message in the chat or send us an email and let us know your thoughts. So today's conversation is with normally my co-host, Davi Sousa, but today he is our special guest. Davi is a CEA and space farming specialist and electrical engineer. He just got his master's degree in electrical engineering a few months ago, so congratulations to Davi. He has experience in CEA, of course, and lots of expertise in smart farming systems, hardware development, control systems, and IoT. Davi works as an independent consultant, a researcher, and he is also the creator of the Space Farming 101 online course, which we host on the AgriTech Designer website. and he's the co-host with me of the SpaceAg series. And his mission is to positively impact people's lives with agriculture, space, technology, and innovation. And more than that, Davi is just a great person. I've been working with him for 2 years on this project, or more than 2 years on the project. First, we created the space farming series together, the online course, and now we've been doing the webinars. And it's just such a pleasure for me to be able to work with him. So,
Same here,
besides,
David.
just a great guy in general. So, take it away, Davi.
Thank you so much. Can you pass the slide?
Yep.
Okay. So, hi everyone. Good morning. Again, good afternoon, good evening from where you're talking around the world. Um, Once again, my name is Davi Sousa. Thanks, David, again for this kind introduction. Today we decided to do something different for this kickoff episode in 2026. So that's why I'm here as a guest speaker, and I'll be talking to you about AgTech engineering for Earth and space. Next slide, please. So the presentation is divided into three main topics. I had the opportunity to create a poll with my LinkedIn connections, mostly composed by agriculture and space professionals asking about their topics of interests. So today I'll be talking about industry trends and technologies, basically giving you an overview what is happening at the space industry right now and how does it link with food production in space. After that, we'll discuss about research and development opportunities, and finally the benefits to Earth, how the space technologies can be transferred to agricultural systems here on Earth. Next slide, please. So I would like to start my presentation providing you a brief historical context of the space sector. So more than 60 years ago, during the Apollo program, when humans have been on the moon before, so the space activities were mainly defined and conducted by the governmental space agencies, such as NASA, European Space Agency, and this is called the legacy space. So during that period, the space technology, space missions, and all the advancement of space was primarily guided by the space governmental agencies. And what changed since then? Now we are in the new space era, or simply new space, which will have not only the governmental space agencies, academia, but also we have the participation of industry players, the companies that are contributing together with the players in the industry to advance the space and space exploration. So, and what is really cool about this momentum of the space industry is that not only that we are sending private missions to the International Space Station, we are also having space tourism happening, but we are about to see humanity returning to the moon with the Artemis program. So very soon we'll have the Artemis 2 be launching to the moon. And what is very exciting about this new period of the space industry is that we are going to send back humans. Not only that, we are sending the first woman, the first person of color, and this time we are going to the moon to establish a long-term human presence there. And for that reason, as a result, most of the space companies, I bring here examples of the big ones, SpaceX, which was focused on building a Martian settlement, they shifted their focus now to build a lunar city. Similarly, Blue Origin stopped their operations of space tourism missions and they started to focus in the lunar infrastructure. Next slide, please, David. Well, and as part of this whole momentum, a lot of things are going to happen and they are slowly happening. So, which I call here the cislunar economy. For those who aren't aware, the cislunar space is anywhere between Earth and Moon. So, of course, we have right now the low Earth orbit operations with satellites, the International Space Station. We'll start having the commercial space stations, but more close to the Moon, we'll have the Lunar Gateway, which is which is a project now that NASA is working with other industry partners, which is basically a space station orbiting the moon. This will lead to build a lunar base, and this infrastructure will scale with the time. We start having moon villages, moon cities, and as part of this whole thing, we start having commercial activity as well. So one example that I bring to you here is the Moon Hotel, which was recently announced by Gru Space, and they are taking reservations for those who might want to spend a holiday or a vacation on the moon. Well, I don't want to discuss the feasibility of this project here, but I want to tell you that the company recently shared a white paper providing a step-by-step process of how they want to do that. So, and this is very exciting because, can you pass the next slide, please, David? Because with all this infrastructure, we are going to also feed the astronauts that will be working in these environments, the astronauts that will be aboard the stations in the Luna City. So we need to feed them. And I'm telling you that we need to feed them locally. We need to produce food locally. And this puts us with some limitations and some logistic issues. So because of that, someone might ask me, why we just don't simply ship the food to them inside a rocket? So this is feasible at the beginning, such as it happens at the International Space Station right now. But with time, once we are scaling this infrastructure, we are having more people there for long term. Let me remind you that every kilogram of food or whatever you put inside a rocket to send to space has a cost. And with this long-term establishment on the moon, it might be more interesting to send an infrastructure that will grow food locally on a continuous basis than just keeping sending them on a regular basis from Earth. Well, I can discuss here about some of the benefits of plants in space, but I will not focus that much on that because it's, well, there is a summary of it on the last figure. But the idea here is that we are not only growing plants to simply do research in space. We need to provide nutritious meals for the crew on a long-term and continuous basis. And this is what we are calling the space food systems. For those who are interested to investigate more and learn more about this topic, a very recent paper was shared where they provided a system level review from food production to space food systems. Next slide, please. Well, I would like to take a bit of time to present you the idea of food logistics in space. So let's say that we can send a greenhouse on the surface of moon, we are put inside of a rocket, but we need to think this, we need to establish a plan to do this in a smart manner because this infrastructure will scale with time. Therefore, we need to think in terms of modularity, scalability, and adaptability of the systems for diverse space mission scenarios. No matter if we are putting the system inside of a spacecraft or to couple this with an orbital station, surface habitats, or transit vehicles, at the end, we will have a station with growth units that will scale with time to increase the production of fresh food on a continuous basis for a crew with a certain amount of astronauts. Next slide, please, David. Well, and what are the ways that we can do that? I will provide you some ideas of what is a research and development roadmap in this field. On the left, there is a usual example that we can just send a specific system, autonomous systems, either inside a rover or a robot in space. We just ship it. The system will conduct the research in an autonomous manner, and we'll gather the data here on Earth. So this is interesting in certain ways, but when we think about some other limitations, first we need to ensure that we have necessary investment to send this infrastructure there. And no matter if you're talking about Moon or Mars, we need to ensure that the system will arrive there in an adequate manner. And last but not least, we need to ensure that the system will operate at the way that we build it to do, like the desired way to provide the scientific outcomes that we are expecting. Well, on the other hand, there is another roadmap that is more accepted in the scientific community, which is basically we should do this in a step-by-step process. We need to learn with the current step, gain experience with this, overcome the challenges, and then we can move to the next step. Imagine that we are learning right now at the International Space Station. We'll move this solution and develop a system for the Lunar Gateway. After that, the lunar surface, and afterwards, the Martian surface. In summary, our food technologies and systems, they must be compatible with the spacecraft that will ship it and the abstract infrastructure that will be there waiting for these systems. So each solution should be considered as integral component of the whole habitat that will be designed to interface with the other technologies that will be aboard, and with that to form a cohesive, adaptable, and functional whole. Next slide, please. Now that you are aware of the roadmap of doing this research, let me introduce you to some opportunities, what we can do with this research. Next slide, please, David. Well, but before, I would like to briefly introduce you to a concept called Technology Readiness Level, TRL, or how I like to call the technology maturity. These are metrics established by European Space Agency and also NASA, but is also accepted in other industry to standardize space technologies. If we want to do this in a way that all the technologies talk to each other, let's say like that, we need to have everyone following the same standards. So we can start with a basic principle with the TRL1 to be observed and reported with time, doing research. And as we improve our solution with the time, we can reach the TRL9 to have a flight-proven solution that have successfully operated in a space mission scenario. Next slide, please, David. Oh, you can pass, yes. As an example, there is the OHALO 3, which is TRL6. For those who doesn't know, the OHALO is the continuation of the food production and plant growth studies at the International Space Station. They aim to send this solution to the International Space Station by the end of this year. But the final goal is to use this solution to grow food for the astronauts to eat there in space and apply this solution also in the Lunar Gateway. So the project is expected to end by 2029, and until there, I'm sure that we'll see a lot of things happening until the system reaches the TRL number 9. Next slide, please. There are also other metrics that we can use in terms of growing plants in space. The first one is the crop readiness level, which basically dictates how ready a certain crop or plant species is ready to grow and be consumed in space. On the left, I provided here some examples of crops that reached the highest readiness level. And more recently, a group of researchers has established the BLSS, or Bioregenerative Life Support System Readiness Level, which is basically take into account the crops with highest readiness level and start testing these crops to be part of a functional bioregenerative life support system, of a functional closed ecological system with regeneration of molecules, regeneration of air, and much other capabilities that are now being used, like are now being developed, being done with physical chemical solutions. Next slide, please, David. So now I will provide you some examples of how this research can be done, how this research is being done. So on the left, there is the Chinese lunar lander payload, the biological experiment payload, which was sent to the moon in 2019, and it's considered the first biological experiment carried by humankind on the lunar surface. Well, this experiment might not be that successful because the plants died in the second day, but at least they were able to demonstrate that plants can germinate on the lunar environment. The upcoming missions will have Artemis III carrying out the LEAF beta payload, and LEAF stands for Lunar Effects on Agricultural Flora, which they send with astronauts to the lunar surface, duckweed, and other model crops to investigate how they will respond to the lunar environment. And this mission is expected to be launched by mid-2027, so next year, hopefully. Next slide, please, David. There are other ways also to do this type of space experiments. We don't need necessarily to send something to the moon. We can do some other things in the low Earth orbit. I bring here some examples for you to be aware. On the left side is an example of a CubeSat, a 3U CubeSat, like 30 centimeters high. And they put it a small growth module to grow microgreens in the low Earth orbit. Another example, one system developed by the Indian Space Agency, ISRO, which they send a small growth chamber inside an orbital platform. And next, you can pass, please, David. And the idea is that inside these payloads, you can conduct a lot of plant biology studies. And I will bring another example of doing that. You don't need necessarily to grow plants in space, but there is some studies related to space mutagenesis, which basically you can send the seeds of the plants of certain space or certain species to be exposed to the space environment. You send it back to Earth and you see how is the gene expression of the seeds here on Earth, if there is any modification caused by the space exposure. I bring here this example, a Space Tango mission, which has sent for the first time hemp seeds in 2019 to space, to the International Space Station, and then they send it back to Earth to conduct experiments with it. Next slide, please, David. Well, there are other ways of doing this, not necessarily to send that to space, but there are many ways to get insights of how a certain biological system performs in microgravity. This example here is with the use of 1D or 3D clinostats, or random positioning machines, RPMs. Basically, the idea of these systems is to minimize the effects of the gravity vector in the payload, what you have in the middle of the system. So I bring here just a few examples of this type of infrastructure, of this hardware. One of them developed by academia, which they conducted research with hydroponics, growing plants inside of this small chamber in the middle of the clinostat. Other solutions can be using 3D printing materials to build your hardware, and also some commercial solutions. We hosted Oreos, and they present in a previous SpaceAg conversation, and they presented the Grav Lab, which is also a random positioning machine developed by the company, and they are selling also this type of solution. Next slide, please. And the last example of an environment that you conduct space research, SpaceAg research, is the space analog environments. But what is a space analog environment and what we can learn from them? So imagine that an astronaut at the International Space Station needs to conduct an extravehicular activity, an EVA. Basically, it is a routine, an operation that he needs to do outside the station. And this is a very risky operation that requires a lot of safety procedures and a lot of training for the astronauts as well. So what does NASA do to minimize this risk and prepare the astronauts for this type of activities? They have a pool that they mimic everything that has at the International Space Station, and they train the astronauts in advance inside the pool. Next slide, please. But we don't need necessarily to put a habitat and astronauts in under the pool to do this type of activities. We can have many space analog stations in extreme environments on Earth, or even in closed environments as well. There are many around the globe. I decided to just highlight a few of them. There's a Chapia, which is a NASA habitat, which was 3D printed, and they are doing really good research there. You can find also this type of space analog stations in desert regions, in a bunker, in a military bunker. But out of curiosity, I decided just to highlight one. That is Habitat Marte, as you can find in the left bottom. And this one with the clothes, let's say analog astronaut clothes, it's me in the semi-arid region of Brazil, where when I was doing training to become an analog astronaut at Habitat Marte. And what is very interesting about this location is because this is considered an extreme environment because it faces droughts, high temperatures. It's basically called the green desert. And I had the opportunity to conduct a lot of SpaceAg research over there. Next slide, please, David.
One quick question. The analog environments, some are for Mars, some are for the moon. Are there for other planets as well, or just those two?
It depends. Some of them for Mars, some of them for Moon, some of them inside a spacecraft. So it depends.
Gotcha. Okay.
Next slide. Well, and I decided to show this, but as I mentioned, there are many others around the world, but I decided to show these ones because somehow they have conducted some sort of space ag related research and development. So as you can see, different systems in different locations, but the purpose is kind of the same. We want to train astronauts in advance to see how they will perform the food-related routines in future space habitats. Next slide, please. Now that we understood there are the opportunities, I would like to move to the last topic of my presentation, which is talking about benefits to Earth. In short, I decided to provide you a real example in a specific industry on Earth that space can be beneficial, of course, linking it with space agriculture. Next slide, please, David. And this industry is the controlled environment agriculture industry, which is an emerging sector. AgriTech and David, Nichols, who is here, Henry, they have been doing a great work in this sector, advocating, conducting analysis, and contributing a lot to the advancement of this sector. And one of these analyses is that they basically compared the boom of the vertical farming industry, which is part of the CEA industry, with the Gardner's 5 phases of hype cycle. I will not discuss in depth about this hype cycle, but what I want to tell you is that after a lot of business failures and bankruptcies in the vertical farming space, the industry is now trying to understand the mistakes, trying to understand the gaps, the challenges, and we are seeing that we are slowly entering in the phase of slope of enlightenment, which is basically the industry is getting back together. And what I want to tell you here is that space farming can also contribute to this momentum of the CEA industry. I decided to highlight here to exemplify more this statement. I decided to highlight here just a few challenges of this sector. First one is a capital intensive sector because it's very challenging to scale the heavy infrastructure of a vertical farm. Also, more recently, AgriTech started to share slowly, but the 2025 Global CEA Census listed that the top 2 operational challenges are energy costs and labor expenses. And also, there are a lot of struggles on system design, financing, greenwashing, and clean energy costs. Next slide, please, Dave. And how does space exploration fits into this context? Space is also booming, and there is a lot of money being put into it, and we start seeing more money being put along the years. But what is really interesting about it is that it's not me who are saying this. The World Economic Forum say that space will be a larger part of the global economy by 2035, and the return of investment in this sector will be more than financial, because space can help us to tackle some of the world's greatest challenges, climate change. Next slide, please. And I will tell you how we can do that. We have a lot of emerging solutions. Here, I decided to just provide you, highlight some that have linked with space that was developed along with the space research, but somehow advanced also what we know now on the CEA industry. The first example, the biomass production chamber, or BPC, which is considered the first vertical farm, which was developed by NASA in the 90s to conduct space farming research. Another example, aeroponics. The term was first introduced by NASA research in 1997, and until now, it has been researched at the International Space Station. Next slide, please, David. Oh, okay. And together with that, we have advanced smart farming systems that can somehow contribute to this whole industry. I would like to just point out a few of them. I'll not go through all the images, but we have artificial intelligence and IoT to allow efficient monitoring and decision making in the industry. We have computer vision and plant phenotyping, which can help us to predict the state of the plant, if the plant needs water or not, and of course, minimize the use of resources. And to reduce labor costs and expenses, we can use autonomous robots, and even drones in this type of infrastructure. Next slide, please, David. Well, and last but not least, this is also another very exciting thing, at least for me, based on my background at semi-arid region of Brazil, being able to work in the desert of Saudi Arabia as well. There is a lot of high-tech farming systems that are allowing us to grow plants, to grow food in extreme environments, no matter if you're talking about deserts, in the Arctic region, even in Antarctica. Next slide, please. As a summary, to summarize my presentation, I would like to tell you that the lunar economy is a massive opportunity that is predicted to exceed $170 billion by 2040. And why this is so interesting for us that we work with agriculture? Because if we use the space environment or space exploration, we can also develop solutions to reach the sustainable development goals for us here on Earth, which means that the space can be used as an incubator to advance sustainable solutions on Earth. More specifically, SpaceAg can be an incubator to advance agri-food tech systems on Earth. Now, with all of this, space programs benefits from scalable and market-relevant technologies, and more importantly, Earth gains resilient, climate-smart solutions with increased technology readiness level. Next slide, please, David. So I would like to conclude my presentation not providing you a quote or a reflection, but an opportunity. If you are into the field, if you want to provide solutions and contribute to the advancement of space agriculture, let me introduce you the Mars to Table Deep Space Food Challenge, recently announced by NASA. The idea of the challenge is for you to design a complete, nutritionally sufficient food system to sustain 15 astronauts on a mission to Mars. There are awards for US teams and recognition for international teams. If you want to learn more, here's the link for it. And just to mention that tomorrow they will have a webinar, the first webinar of the competition. So this is the moment. If you are interested, take a screenshot of the slide and you can find the link to register in the bottom of the slide. Next one, please, David.
And Davi is one of the judges for this competition. Is that right, Davi?
Yes, yes,
Okay.
I'll be there as well.
Okay, awesome.
So I would like to conclude saying thanks to all of you for the attention. So if you are ready to become a space farmer, do not hesitate to contact me. Here are my contacts and let's connect. I'll be more than happy to keep in touch with you all. Thank you.
Amazing. Thank you so much, Davi, for that great presentation. We have, before we get into Q&A, I think we have a couple of polls that we just want to do really quickly. So I'm going to stop sharing here and maybe Nico, you can go ahead and share those polls. Okay, the first one, yeah, tell us about yourselves. Are you a student? Are you in the vertical farm, the CA industry? Are you in the space ag industry? Let us know.
I could highlight all of them as usual.
You can only choose one, so choose the one that most applies to you.
Oh, of course, I am not an enthusiast, a SpaceAg lover.
Okay, we'll give this a few more seconds and then we'll see what are your thoughts? You think we have mostly students on here? Do you think we have researchers? I'm going to guess researchers. I think people who are,
Hmm.
but what's your guess, Davi? What do you think will be the largest group?
Since I saw some familiar names from previous webinars, I would say we have a lot of SpaceAg enthusiasts as well.
Yeah, I agree. Okay. Nico, what does the poll say?
Ooh, very
Oh,
balanced.
researcher was number one. So 27% of you all are researchers. Um, Second place, consultants, and then other and students third. Um, Greenhouse vertical farm grower, 10-11%. And then I'm guessing that everyone is a space ag enthusiast just by the fact that they're
They are
joining
here.
joining
Yes,
this
that's true.
webinar. For all
That's
the
true.
researchers, we would love maybe some of you could be interviewed in future sessions of Space Ag Conversations. So feel free to share with us more about your research that you're doing, especially if it's related to Space Ag.
Yes, that's true.
Okay, and then a quick second poll just to get everyone's location. Nico, can you? And then we'll start with questions. Okay, so where are you located?
I think it will be well balanced as well. So from the beginning of the presentation.
Yeah.
And if you already responded, the poll, start thinking on the questions that you have. Feel free to send in the Q&A part or in the chat. We'll go through them very soon.
Okay, you want to show us the results of this one, Nico? Close this one and okay,
Oh,
so it's a pretty good mix. North America most common, then Europe, Asia second, 28%. Okay, we need more representation from South America
I
for
agree
sure.
with that. I agree with that.
Okay, so let's start off our Q&A. I have one question for you just to get things started. Um, so it sounds like we're moving from a reality where we're shipping food, we're shipping final food products to moving the kind of like farming infrastructure into space, right? And I
Yeah.
wanted to ask you about like fertilizers because um, right? Because before we've just been shipping food products. Now, theoretically, to grow the plants in these farms, they're obviously gonna need fertilizers. Are those fertilizers able to be mined or sourced in from the moon or from space in some way, or will those need to be shipped via rockets to space?
And this is an excellent question, David. So, I would say that similar as I answered the question is like, of course, we will need to ship them at the beginning. Um, Even though with the long-term establishment, we still might need to ship them, but in less amounts. Why I'm saying that? Because of course this is a transition. First, we'll start growing the plants, and after that, with that actually, we need to also reuse the waste, the non-edible biomass, let's say like that, from this plant. So like we can also start integrating this in a imagine like a space composting system that will allow us to recycle most of the nutrients that are still available in that organic matter. Um, After that, we also have a lot of efforts being put into I didn't mention here, but it's called in situ resource utilization. So imagine using the resources that we have available either on the surface of Moon or on the surface of Mars, and we extract them and we turn them into some sort of compost that is useful for the systems. So and another example for that is like using the Martin regolith as to like process this Martin regolith, and you can add just a few of a little bit of that organic compost that might be useful to provide nutrients to the plants. Um, Also, Greg mentioned here, one second. Greg mentioned here about the use of anaerobic biodigestion. Also, we have algae systems that will be part of this big bioregenerative life support system that will allow us to keep the nutrient production over there. So with time, it's expected that we'll reduce this need to ship nutrients and we'll start to producing them locally as well.
Okay, and this also will definitely like spur technology on Earth, right? Because being
Of course.
conserving nutrients in space is going to be so much more important, right? Being able to reuse our nutrients through multiple crop cycles, et cetera, is going to be so much more important in space than on Earth. That the sensor systems that will be developed and the monitoring systems for those applications, they'll be first developed in space, but then that technology will then filter down to Earth. And so that's another good example of kind of the
Yeah.
technology transfer from space to to Earth
Yeah.
farming.
If I would just highlight here two examples. I'm sure I know that there is a company in the Netherlands that they are working with wastewater treatment for agriculture, and they are kind of a space spin-off. It was from a previous ESA engineer, like the founder of this company. And there is also another company in Europe as well, I think in the Netherlands, that they are working with direct carbon capture. So they are capturing the carbon from terrestrial atmosphere, let's say like that, and they are putting inside the greenhouses. So these are space spin-offs. Like the companies started like with space research, and they started developing solutions back to Earth.
I'm looking at the
Oh,
questions that
David?
have come in. We've had a lot of questions. Is there one in particular that you want to answer, or
Let me check here.
someone's asking about diseases in space? I guess how do we control diseases in space? About growing media in
You mean
space?
ah. So in terms of
Yeah.
that, one of the like the things that is very needed in space exploration, every time we are sending some system from Earth to somewhere in space, this system needs to pass along of many like sanitation procedures, because what they want to avoid is they call it, this is called planetary protection. They want to avoid that if we send something from Earth in a system and this reach on Mars, for example, we might create some sort of catastrophic thing. No, no, just kidding. But like this might initiate some sort of organic, chemical processes or something that are not desired in these future environments, in the space environment. So there is a lot of procedures for planetary protection. They want to minimize the most. Of course, they already found like some microbes in the International Space Station, for example. Humans will be there as well. So there are ways to sanitize and minimize the effects of this. And with plants, I would say there is also solutions that are being developed to kind of control more the development of pathogens, of not beneficial pathogens. They want to make sure that most of the microbiome and microbial activity is beneficial for the whole habitat.
What about continuing with microbiome and stuff like that? What about mushrooms? Someone asked about growing mushrooms in space. Are you aware of any trials with mushroom production in space, and how did that? What were the results of those trials?
I'm not directly, I would say, aware of, like, I know that there is a group doing research on that in the US, if I'm not wrong, at Purdue University. They have been investigating the use of like mycelium in space, but I'm not aware of the results of or how this research topic is evolving.
Okay, let's see what else. Um, there's a question: how do you capture sufficient sunlight to complement using LED lighting? What would be the
So,
yeah? What would be the lighting systems in a lunar farm?
yeah, there are some concepts that they propose the use of. Imagine like a lot mirrors that you direct the sunlight, at least on the surface of moon. Um, you direct the sunlight to the habitat, and you can use it like imagine like a capturing system, for example, with fiber optics or mirrors that you can bring back inside to the inside environment the sunlight that is reaching the moon. So these are one of the concepts that are proposed. Even like the University of Arizona, we had the Professor Murat Kassira here. I'm sure like he somehow got engaged in this type of research. There is a publication discussing about this. So this is one thing. But when we are talking about Mars, for example, we are talking about a planetary body that is way more far of the sun than Earth. So the amount of light that reaches there on Mars is lower. Um, but it's still like since Mars doesn't has an atmosphere, there's a lot of radiation as well. So at the same time that you want kind of provide light, you want to avoid the radiation, the ionizing radiations to reach inside the habitats, to reach the plants, because they are not, they might harm the plants. So I would say that on Mars specifically, these habitats might be in Mars cave, like imagine like caves, like they will be under the surface of Mars. They will be covered to avoid radiation to reach the habitat. So most of the farming systems on Mars, I would say that they will be using LED light. They will not be using sunlight.
Okay. We had an interesting question about what keeps you up at night as a space ag expert. Kind of what is the potential failure, or maybe I guess that's what this person's asking. What's the bad scenario that kind of
Yeah.
keeps you up at night?
Oh, this is a great question because I would say from my personal experience at Habitat Marte, like the day that oxygen pump stopped to work, like it got clogged in the system, and basically like it started like the plant. I woke up and the plants were dead, like were almost dead. So you need to try to recover the system. So having this type of like shortage or problem that like make the system stop, I think this is something that in one way might keep the astronauts like very concerned about the operations and how things are going. Um, but of course, there's a lot of redundancy in the space environment. So they will not like, okay, if one pump fails, most probably, if we are talking about the use of AI and smart systems, there will be a replacement, like a pump that is already there that you just like shift the water passing out the oxygen pump. You put a new oxygen pump to operate. So it's like a pass by solution. So this is one of the things as an engineer also I think this would be the thing that would keep me up at night. But on the other hand, I think if we are talking about for example long-term mission on Mars or something like that, if the habitat kind of lose its isolation capacity, so like imagine losing part of the food production that you have there, or even though they are shipping the food in a rocket, the rocket doesn't reach there in the proper manner. So, like you are talking about a long-term mission that is a kind of survival mode. So that is something that, as an astronaut, I would be worried as well.
Okay. We had a question about how harvesting is done in space. Um, I think I think mostly the to date the crop production in space has been very small, so the astronauts are doing the harvesting manually, and it's something to help kind of keep them entertained and help them connect with nature because we know that like biophilia is also important, right? Having that connection with nature. But I would assume that in the future there'll
David?
be more automated solutions. Oop, did my Wi-Fi go out?
No, we can hear you. I think Dave is out.
Okay, I
You
think Davi's having some maybe a technical problem. Um,
I think it cut a bit your voice here for me.
okay, we think you're having some technical issues, Davi.
Hi,
So let me just,
can you hear me?
yeah, you're back now.
Okay. Sorry about that internet connection. I changed it here.
No problem.
So you were saying something
Um,
about automation, David?
I was saying that someone asked about the harvesting in space, and I said, I think that to date, most of the crop production has been very small scale, and so it's mostly done manually by the astronauts. And that it's good for them also to have the contact with the plants, and because of course, being in space for so long, it's important. But in the future, I would assume on a larger scale that there would be automation around the harvesting.
Sure. Yeah, like imagine the astronauts, they work almost all the time. So when they are not sleeping, they are doing some sort of activity or something like that. They cannot spend all the time that they have with the plants. This will be more controlled in terms of like if they are going to reach the plants, might be to promote this benefit, this psychological benefits for them, then just like they are obligated to go there and harvest. So this will be controlled, of course, at certain point in the future.
Yeah, for sure. Okay, let's see. We probably have time to take a couple more questions. Is there a current plan for food prep and storage post harvest? That's interesting. Are we going to
Hmm.
have are we going to have refrigerators on the moon? Is that how post harvest will work there, or are we going to be like drying foods or processing them in other ways? What's kind of the most efficient way to do it in space?
So I would say that the combination of all solutions I would say that these are welcome. Like, of course, there is the need to keep the food fresh for the astronauts, and there is this also in parallel. There's also this need to keep some sort of storage in case of like some failure in the production or something like that. So you need to keep it to make sure that they will have food. That's why storage is important. But I would say that such as we have now, there are microwaves like that will heat the food. Like you can freeze dry the food at the beginning, and then like you can add water or you can microwave to reduce to not eliminate, but at least reduce the amount of water to keep to increase the shelf life of that specific food. So I would say in a future space like more like scalable scenario, we might have like the combination of this type of solutions as well.
Okay. What else do we have going on? Let's see. Do we have any? Most of the people are asking like, what's going to be the first crops that are grown on a large scale in space? It seems like most of the experiments have been with leafy greens. Um, do you Would you predict that like the first crop that's grown on large scale in space would be leafy greens, or would it be something else that's maybe like harder to move, harder to transport, maybe something like tomatoes, which are heavy and a lot of water, and or what's your prediction on what do you think the first crop will be?
So I believe that leafy greens, of course, it's like what is happening right now at the vertical farming industry. So it's easier, you can produce more, you can scale easy, like the management of the system is like more simple in terms of nutrition as well, the light requirements, so many things that like somehow easier to handle. Of course, like now in space at the International Space Station, a lot of leafy greens research has been done with veggie and APH. Specifically, APH had the opportunity to grow even peppers. So we are talking now about other type, also wheat, and we are talking now about other type of species that can be grown in the space environment. Of course, the APH was more focused on research, not on food production. It was plant growth research, not food production in space. The Ohalo tree will change this conversation with the time, but the idea is that we will slowly shift from the leafy major part of leafy greens. We'll start adding like others food other food crops as part of the system. And I would say that if we start thinking about that from the beginning, we can start preparing these systems, the future system, the future infrastructure that we are shipping to the moon, for example. We start preparing them to like get more higher crops. So like tomato plants, more the wheat, or like more staple crops that are be like more that will combine most of the food needs of that will provide most of the food needs of the astronauts. Um, but also, with the time, as I presented the bioregenerative life support system readiness level, it's not only about the crops that they grow and they consume. Like after a while, we also need to ensure that we have enough food for the astronauts, but after that we also need to ensure that crops will be part of the functional whole bioregenerative system. So we are talking about crops that are more efficient with air revitalization, in just like capturing CO2, providing oxygen to the habitat, doing also like water we use, and so on. So like we'll have the combination of this type of crops as we start scaling this type of infrastructure.
Yeah, we really need to think about this in a systems, a real like systems thinking manner versus um, maybe on Earth we don't often think about things in that way, and we end up with a lot of waste and inefficient systems. So if you had questions today that didn't get answered, feel free to message Davi on any of these different platforms with your questions. We also have a newsletter, a SpaceAg newsletter that comes out. And so if you want to get signed up for that, we will let you know. We've done the Q&A. Just reminded everyone, I'm with AgriTech. If you have any needs around projects on Earth, we don't do anything in space, but if you have any questions
Yet.
about CEA on Earth, feel free to reach out. And to remind everyone, we have, just like this content, there's an even better course, which is available online at design.agriculture.com. It's a space farming 101 course that we made together, but Davi is the teacher of this course. So I'd encourage folks to check that out, please. And we're giving away a certificate, right, Davi?
Yes, for those who stayed with us until now, we have the questionnaire for those who are interested to claim the certificate. So either let me add here on the chat this link so you can use the QR code, and you can answer. Once you answer, provide the information. I will also share a keyword. And as part of this, you can also click to be added to the newsletter email. So like once you answer this form, you'll be contacted with the certificate and will be also added to the newsletter.
And
So
Davi does the newsletter every month or so,
yes,
and that has updates on what we're doing on the SpaceAg conversations, updates about the industry, et cetera, et cetera. So, what is
and
the
for those,
keyword, Davi? What is the
yes, for
keyword?
those
People want to
who are
know.
asking, the keyword today will be SpaceAg. So let's do
SpaceAg.
SpaceAg. This you cannot forget.
And even if you do forget, you can ask one of us and we'll remind you. So,
Exactly.
all right. Well, thank you, Davi, for an amazing presentation. Thank you, everyone, for joining us from all around the world. We love seeing people from all around the world. If you have, once again, ideas for guest speakers, let us know. Connect with us on LinkedIn, on Instagram, on any of your social medias. And yeah, have a wonderful day.
Thank you very much, everyone. It was a great pleasure once again, and we look forward to have you all with us in the next episode of the SpaceX Conversations.
Probably it will be sometime in May, we're thinking, for the next
Exactly.
one.
We'll be
Yeah.
contacting and we'll be sharing more information about that. Thank you so
Okay.
much.
Take care, everyone. Have a wonderful day.
Bye, everyone.